Good morning, dear students. Today we are going to start from a new chapter. That chapter's name is Dynamics. My name is Ferhan Mazher, and today I am with the 9 metric class. The subject we are studying is physics. And the first thing which we are going to do today is that we are starting a new chapter, and that is chapter number 3 from the 9 metric syllabus. And the name of the chapter is Dynamics, chapter number 3. So it is about the force and the effect of the forces on the bodies. So the first thing which is coming up into your way is we will talk about what is force. You see, force is an agent which tries to produce motion, or it tries to stop motion, or it can be means whenever you apply this agent, which is force, you actually tries to change the state of motion. You actually change the state of motion, or you try to change the state of motion. Okay, so that is called force. Okay, so for example, in the diagram, you can see that a boy is pushing. For example, if you look at this diagram, that a boy is pushing on a wall. He's applying force, but the wall will not move. So the boy is trying to produce uh, motion in the wall, but he's just trying. He cannot produce motion in the wall. So the push or the pull which he is providing, that is known as force. And here you can see this: the ball was coming towards the batsman, and when he will hit the ball with his bat, what will happen? The direction of the ball, the motion, the direction of the motion of the ball, that will change. So here the ball, its motion has changed. So here he provided you can say a push or a pull, and due to that the motion of the ball has changed, its direction has changed, its magnitude as well has changed. So so force is basically an agent or a push or a pull which tries, which changes or tries to change the motion of a body. For example, if you look at this diagram here, somebody has kicked the ball, and the goalkeeper has, by applying the force, he has stopped the ball. So he has, by applying the force, he has changed the state of motion of the ball. Another very important thing: when the ball hits the man, he might fall backward. So when the ball applied the force on the man, and what happens, that the man who is just standing there, the goalkeeper, he's just standing there, due to the force of the ball, he might fall backward. So you see, whenever a force is applied on a body, um, there there can be some visible effect in the state of motion. The body might start moving, the body might stop moving due to the application of the force, and the body might start moving faster due to the application of the force, or the body might start moving slowly due to the application of the force. So whenever you apply force, the there will be a change in the state of the motion of the body. The force is measured in Newton. Remember that the force is measured in Newton. Okay, so Newton's laws of motion are of fundamental importance in understanding the causes of motion of a body. Before we discuss these laws, it is appropriate to understand various terms such as force, inertia, and momentum. So, in this session, we are talking about force. We will talk about inertia later, and momentum also. Force. We can open a door either by pushing or pulling it. Pushing means you push, and pulling means you pull it. Okay, pull it, pulling it in figure 3.1. The figure 3.1 shows a man pushing a cart. Let me see 3.1. Okay, So here we have the diagram 3.1, the food vendor on move. So shows a man pushing a cart. The push may move the cart or change the direction of its motion. Yes, the magnitude of the motion will change. I mean, the speed will change, or the direction of the motion will also, can also change, or may stop the moving cart. A batsman in figure 3.2 is changing the direction of a moving ball by pushing it with his. A boy is pushing a ball and is thus trying. Could he move the ball? A goalkeeper needs a force to stop a ball coming to him. Thus, we understand that or tends to move, stops or tends to stop the motion of a body. The force can also change the direction of motion of a body. Okay, so that's the definition of the force. A force moves or the force can also change the direction of motion of a body. To change the shape or size of a body, that what a force can do. The force can change the direction, it can change the direction, sorry, the force can change the direction of the motion, the force can change the magnitude of the motion, the force can stop a body, moving body, force can cause a body at rest to move. The force can also change the size and the shape of the body. It's a very famous MCQ. But the force cannot change the mass of the body. It's a very, very famous MCQ. Okay, what the force can do and what the force cannot do. Okay, inertia. You see, let me give you a very good example. For example, if you are sitting in a car, the car is at rest, and all of a sudden somebody, your driver, accelerate the car. He pushed the accelerator and your car moves forward. Whenever the car moves forward, your body goes backward. Okay, when the car moves forward, your body goes backward. Okay, so when, for example, if the car is going smoothly on a constant speed, all of a sudden the driver applies the brakes. So what happens? Your body is pushed forward and you are in danger of colliding with the dashboard. Another very good example. For example, here they have shown an experiment. So what you do, you take a cardboard, a hard, what you say? It's a, it's a cardboard, like a card, and you put it on a glass. And then you take a coin and you put the coin on the card, and with your finger like this, like we play carom board, you hit the card with your finger. So what will happen? The card will fly away, but the coin will not go with the card. It will fall into the glass. Amazing. As the card started moving, your body says, I don't want to move. So you are pushed backward. You feel a jerk in the backward direction. Another good example is, for example, your car is going at a constant speed, let's say at 50 kilometer per hour, and all of a sudden you apply the brakes. So the car will suddenly stop, but your body will say, I will not stop. I will go forward. I will continue my motion. So your body moves forward. The car stops, but your body moves forward. That's why you collide with the windscreen or the dashboard. In this case, the coin, the cardboard moves. The card moves underneath the coin. The card is gone. When you hit it with your finger, it's gone. It fly away. But the coin says, "I don't want to move." So that's why he falls into the glass. Here they have shown another good example. Uh, they have taken a paper and they have put some coins on top of each other, and then what he do, it holds the paper, and all of a sudden he pushed that paper underneath the coins. The paper will come out, but the those coins will remain there. The paper moved, but the coin said that we do not want to move. So you see, it's a characteristic of the bodies who have mass that they don't want to move. They don't want to change their state of motion. So remember these words. So the bodies, they don't want to change their state of motion, whatever is their state of motion. If they are at rest, they want to remain at rest. If they are moving at a certain speed, they want to move at that certain speed. They don't want a change. So the bodies who has mass, they don't want a change in their state of motion. So whenever you try to change their state of motion, they resist. So for example, if I am sitting in the car and all of a sudden the car says I am going forward, but my body will say, no, I don't want to go. So my body will resist the state of change in any change in the state of motion. My body will say, I want to remain at rest. So that's why it tries to remain at rest. That's why I go backward. So when you are going forward in a car at a certain speed, and all of a sudden the brakes are applied, the car stops, but your body says it resists any change in its state of motion. So what happens? Your body says, I want to continue with that speed. So that's why your body goes forward. The coin which you put on that card, the the card is gone underneath that coin, but the coin says, I want to keep my state of motion. It is at rest. It says, I want to remain at rest. So if you try to change its state of motion, it resists. That's why the coin remains there and falls into the glass. In the same way, you have this paper here. The coins, you move the paper moves, but the coins are at rest. They want to remain at rest. They resist any change in their state of motion. So you see, this is the characteristic of all the bodies who has mass, that they resist any change in their state of motion. If they are at rest, they want to remain at rest. If you try to move them, they resist. If they are moving and you try to stop them, even then they resist. They want to remain in their state of motion, whatever is their state of motion, whether this is rest, moving, constant speed, moving with a constant speed, they want to keep that state of motion. So inertia means that the bodies who has mass, they oppose any change in their state of motion. That's known as inertia. And the inertia depends upon the mass of a body. If the mass of the body is larger, there's larger amount of mass in a body, its inertia will be larger. It means it will give you more resistance or opposition to the change in the state of motion. So inertia, Galileo observed that it is easy to move or to stop light objects than heavier ones. Heavier objects are difficult to move, or if moving, then difficult to stop. Newton concluded that every body resists to the change in its state of rest or of uniform motion in a straight line. We called this property of matter as inertia. He related the inertia of a body with its mass. Greater greater is the mass of a body, greater is its inertia. Inertia of a body is its property due to which it resists any change in its state of rest or motion. So that's the definition of the inertia. Inertia of a body is its property due to which it resists any change in its state of rest or motion. Let us perform an experiment to understand inertia. So here we have experiment number one. He says, take a glass and cover it with a piece of cardboard. Place a coin on the cardboard as shown in the figure 3.5. Now flick the card. Flick means to okay. Flick the card horizontally with a jerk of your finger. Does the coin move with the cardboard? The coin does not move with the cardboard due to inertia. The coin will not go with the cardboard. It will fall into the glass. Where does the coin go as the cardboard flies away? The coin will drop into the glass. You can do this experiment at your home. Where does the coin go as the cardboard flies away? Consider another example of inertia. Cut a strip of paper, place it on the table, stack a few coins at its one end as shown in the figure 3.6. Pull out the paper strip under the coin with a jerk, okay? Give it a jerk and see what will happen. Do you succeed in pulling out the paper strip under the stacked coins without letting them to fall? Why do the coins remain stacked on pulling out the paper strip quickly under the stack? So I hope that you have understood this. Do you understood the inertia? Hello? Yes. Okay. Now we are coming to another very interesting term. This is brand new word. We call it momentum. So it's now being added to your vocabulary. The word is momentum. You see, the momentum actually means very simple definition of the momentum is the product. Product means multiply. Okay. So the momentum is basically the product of the mass of the body and the speed of the body. Momentum, I said speed, it's basically the velocity. So the momentum is basically the product, means multiply, a product of the mass and the velocity of the body. So, for example, if I know that I have a ball, for example, which is of 2 kg, a cannon, the ball which is used in the gun. So we have a cannon which is of 2 kg, and suppose it is going at a speed of, suppose it is going at the speed of, let's say, 30 kilometer per hour, suppose. Okay. So what will be the momentum? The momentum is the product of mass and velocity. So momentum of that cannonball will be mass multiply velocity. So mass is 2 kg and the velocity is 30 meter per second. So just multiply them. So you will have 2 multiply 30, it will be 60. And the unit of the, means the momentum, the mass is in kg, the velocity is meter per second. So the unit of the momentum will be kg meter per second. You understand? The unit of the momentum will be, because the momentum is the product of mass and velocity, the mass is kg, the velocity is meter per second. So the momentum will be kg meter per second. So Momentum is very simple. You see, somebody asks, what's the momentum? Momentum is, and it's very important, momentum is the product of the mass and the velocity. For example, God forbid, but for example, if a cycle is coming at a speed of, suppose, the weight of the cycle will be like maybe 40 kg, maybe. And let's say the cycle is coming at a speed of 10. So its momentum will be, okay, forget the momentum. So suppose that the cycle is coming at a speed of 10 towards you. And then in another scenario, a train is coming, a train engine, locomotive, a locomotive is coming towards you. And suppose the mass of the locomotive is like 5,000 kg. Suppose the mass of the train engine locomotive, the train engine, is 5,000 kg and it is coming at a speed of 10 meter per second. So the cycle is also at the speed of 10 meter per second and the locomotive is also at the speed of 10 meter per second. And for example, if a car is on the track, when the car is hit by the cycle, which is at 10 meter per second, the car is stationary. The cycle hits it with at a speed of 10 meter per second. Imagine that scene, that a cycle hitting a car at the speed of 10 meter per second. And then imagine a train hitting the car, a locomotive hitting the car at a speed of 10 meter per second. Speed is same for locomotive and for the cycle. So which will cause more damage? Which can cause more damage? What do you think? Train, yeah, the train will cause more damage. The reason is the momentum. You see, whenever I talk about the things colliding with each other, we talk about momentum. So we do not check on the speed only, we do not check the mass only, we always check the momentum. For example, bullets. Bullets mass is very small. For example, it is, let's say, 4 gram. The mass of the bullet is 4 gram only. But the bullet moves with the speed of, let's say, 40 meter per second, for example. So the momentum of the bullet is high. The mass of the bullet is very small, but because its speed is very large, speed is very high. So that's why its momentum is high. So that's why the bullet can cause a lot of damage. Okay, so momentum. A bullet has a very small inertia due to its small mass. But why does its impact when it collides with something? The impact is so strong when it is fired from the gun. On the other hand, the impact of a loaded truck on a body coming its way is very large, even if the truck is moving slowly. To explain such situation, we define a new physical quantity called momentum. Momentum of a body is the quantity of motion it possesses due to its mass and velocity. So the definition of the momentum is momentum of a body is the quantity of motion it possesses due to its mass and velocity. The momentum P of a body is given by the product of its mass and velocity V. Thus, P is equals to mv. Momentum is a vector quantity. Its SI unit is kg meter per second. So that was the momentum. So you have learned about 3 terms. First term is force, the second term is inertia, and the third term is momentum. So, can anybody tell me what is momentum? Anybody who will like to tell me what's momentum? The shortest definition of momentum. Definition means what's the formula for momentum? And everybody understand what's the meaning of the product. Product means to multiply. Okay. Okay. So Newton's laws of motion. Newton was the first to formulate the laws of motion, known as Newton's laws of motion. The first law is very simple. First law says that if a body is at rest, if a body is at rest, if there is no, if there is no, we say it, net force acting, or there is no unbalanced force acting, the body at rest will remain at rest. Okay. So Newton's first law is very simple, that it says that a body which is at rest will remain at rest unless you apply a net force, unless you apply a force which is not balanced. So the body which is at rest will remain at rest. That observation is very good and easy to understand. For example, if I put something on this table, and if no net force acts on that body, it will remain at this table. 1 year, 2 year, 3 years, 7 years, 10 years pass, but that thing will remain here. It will remain at rest unless it is acted upon by a net force or a unbalanced force. Then it can move. But if no force, unbalanced force acts on it, it will remain at rest. So this part of this law is very easy to understand. The second portion of that law is easy to it's not easy to understand, comprehend. It says that the body which is moving, a body which is moving, it will continue moving forever. A body which is moving, it will continue moving forever if no net force is acting on it. If all the forces acting on it are balanced, so the net force is zero. If there is no unbalanced force acting on a body and the body is moving, it will continue moving with that uniform speed forever. Forever. This is not our observation. You see, we see that when I move, let's say I have a marble, marble, those small balls of the glass, marble. So when I roll a marble on the floor, the Newton said that it will roll forever. But when I roll actually the marble on the floor, the marble stops after 3-4 feet. Or let's say 5 feet, 6 feet. It stops, eventually it stops. But for example, if I throw a ball, if I kick a football, the football moves and then it stops. You see, the reason is because the football is being acted by the forces which are not balanced. That marble is being acted upon by the forces which are not balanced. When the forces are not balanced, there are unbalanced forces. When there is net force acting on the ball will stop. And those forces are invisible. So the friction it is having with the floor, we don't see it. The air resistance which it is getting, we don't see it. That's why we are wondering why it is not continuing motion forever. But the Newton's first law is very simple. It says if the forces are balanced, the body at rest will remain at rest forever, and a body moving with the speed will continue moving with that speed in that direction forever. Okay. But this all happens only if all the forces are balanced. For example, you must have seen in the film Gravity, and that in the space, what happens if a astronaut starts moving in a certain direction, it will continue moving in that direction, continue moving in that direction. So that is there you can observe that thing. But here we have lot of forces acting on the body which are invisible to us, and we don't even notice them, and they stop the body. So Newton's first law of motion is very simple. Let me read it for you. You say the first law of motion deals with the bodies which are either at rest or moving with uniform speed in a straight line. According to Newton's first law of motion, a body at rest remains at rest provided no net force acts on it. This part of the law is true as we observe that objects do not move by themselves unless someone moves them. For example, a book lying on a table remains at rest as long as no net force acts on it. Similarly, a moving object does not stop moving by itself. A ball rolled on a rough ground either stops earlier than that rolled on a smooth ground. It is because rough surfaces offer greater friction. If there would be no force to oppose the motion of a body, then the moving body would never stop. Thus, Newton's first law of motion states that a body continues its state of rest or of uniform motion in a straight line, provided no net force acts on it. It's very famous statement, Newton's first law of motion. A body continues its state of rest or of uniform motion in a straight line, provided no net force acts on it. So that was the Newton's first law of motion. Do you understand this? Hello, do you understand? You got the idea of what is Newton's first law of motion? Yes, sir. Okay. Net force is a resultant of all the forces acting on a body. Okay. Net force means the resultant of the. Since Newton's first law of motion deals with the inertial property of matter, therefore, Newton's first law of motion is also known as law of inertia. This is also known as law of inertia. We have observed that the passengers standing in a bus fall forward when its driver applies brakes suddenly. It is because the upper part of their bodies tend to continue their motion, while lower part of their bodies in contact with the bus stops with it. Hence, they fall forward. When a bus takes a sharp turn, passengers fall in the outward direction. It is due to inertia that they want to continue their motion in a straight line, and thus falls outwards. So that was Newton's, the first law of motion, and chapter number 3 we are studying. So I think this is enough for today, because at 10 o'clock your lesson will be over. So today we have studied force, we have studied inertia, we have studied about momentum, and then we have studied about the first law of motion. So I hope that this is fruitful for you. Okay, so you can read this again. I have tried to explain it, and I have also read it from the book. Okay, so hopefully you understand this. Okay, so I will stop the recording. So thank you very much, everybody, for joining me for this class. So it was a pleasure teaching you all. So thank you very much. Have a good day, and God bless you all.